guys, today's lesson is on Chapter 5, Section 5, Factoring Polynomials, specifically the two methods called the sum of cubes and the difference of two cubes. As you can see on the right-hand side, we have two models of the factors of the sum of two cubes and the difference of two terms being cubed. As you can see, the two models are very, very similar of the two factors. The only difference are the signs within the factors. For example, the sum of two cubes in the first factor starts with an addition sign, and the difference of two cubes starts with a subtraction sign. Going on to the next factor, the sum of two cubes then has a subtraction sign and an addition sign, where the difference of two cubes has two addition signs. As you can see in the models that we have A and B, which represent the first term being cubed and the second term being cubed. Once you could write an expression as a sum of two terms being cubed or the difference of the two terms being cubed, you could then take the first and second term, substitute it into the model, and get our two factors. For example, problem number 1 has an addition sign. So what we're going to check to see if we could do is write that expression or write that binomial as the sum of two terms being cubed. First question to ask yourself is, what times itself 3 times would give us 8x cubed? That would be 2x. 2x times 2x times 2x is 8x cubed. And can I make the second term into one term being cubed? What times itself would give us 27y cubed? That would be 3y. Since in this case I can write the binomial as the sum of two terms being cubed, I can then follow along with the model at the top here for the sum of cubes in order to write the two factors, or the two expressions that would multiply together to get our original binomial. In this case, A is the first term being cubed, which is 2x, and B would be 3y. So the sum of two cubes start off with A plus B, in this case would be 2x plus 3y, times A squared, which is 2x squared. Notice I'm putting the term that I'm substituting in for A in parentheses, and I will do the same for B as well, minus A times B, 2x times 3y, plus B squared, or 3y squared. The last thing we need to do is just simplify, especially the second factor, and our two factors, the first one would be 2x plus 3y, the second would be 4x squared minus 6yx plus 9y squared. In problem number 2, we're going to have an additional step in which every time we factor, we should always ask ourselves if there's a GCF. For problem number 1, there wasn't any number that went into 8 or 27 other than 1. In addition, they had no variables in common. In problem number 2, however, we're going to see that these two terms do have a GCF, in which we're going to factor them out first, and then check to see if we could continue to factor with either the sum or difference of two cubes model. In these two terms, the GCF, or the term that they have in common, would be x. So what we're going to do first is divide the GCF out of the two terms. That would leave us with x times 64x cubed plus y cubed. Let's continue to see if I could further factor the binomial that we have left. Since it's an addition sign, and we do have the exponent of 3 in both of those terms, let's check to see if I could rewrite that binomial as the sum of two terms being cubed. Ask yourself, what times itself 3 times would give us 64x cubed? That would be 4x. 4 times 4 times 4 is 64. And what times itself would give us y cubed? That would just be y. Just like problem number 1, since we can write those two terms as the sum of two terms being cubed, we could then use the model at the top for the sum of cubes to write the two factors. The first factor, a plus b, would be 4x plus y, where in this case, a is the 4x and b is the y, times a squared, which is 4x squared, minus a times b, which is 4x times y, plus b squared, which is just y squared. Just like the first problem, let's go ahead and simplify that second factor. First one staying as 4x plus y. Those are not like terms, so we can't combine them. 4x squared would simplify to 16x squared minus 4xy plus y squared. These two expressions multiplied together would give us 64x cubed plus y cubed. Those are the factors to that binomial. However, all of the factors for our original problem, we can't forget to include our GCF of x, in which would go into the front of our factored form. In this case, the binomial that we have in problem number 2 have 3 prime factors. Problem number 1 and 2 were examples of the sum of two cubes, in which in problem number 3 and 4, we're going to see examples for the difference of two cubes. Again, the models are very similar. However, as you could see in the difference of two cubes now, we just have to pay attention to the different operations within the two factors. So let's go ahead to first check always if there's a GCF, which in this case there is, in which the GCF would be 5y, as 5 is the largest number that would go into 5 and negative 320, and both of those terms also have a y. In order to factor out the GCF, we're going to divide those terms by the GCF and see what we get as the remaining expression. So we would have 5y times y cubed minus 125z cubed. Let's continue to check to see if we could continue to factor the binomial that we have left over. We have a subtraction or a difference sign. So let's check to see if we could write that expression as a difference of two terms being cubed. If we can, we could follow along with the second model at the top for difference of two cubes. What term or what expression times itself would give us y cubed? That would just be y. And what expression times itself 3 times would give us 125z cubed? That would be 5z. Since I can write this expression as a difference of two terms being cubed, we could follow along with the difference of cubes model in order to write its factors. First factor being a minus b. In this case, a is y and b is 5z. So we will have y minus 5z times a squared, which is y squared, plus a times b, plus b squared. Simplifying us will give us the factors y minus 5z times y squared plus 5yz plus 25z squared. We must not forget that once you take out a GCF, we're going to make sure that we include that in our factored form, in which, like problem number 2, the binomial in 3 have 3 prime factors. What I'm going to ask you guys to do is try number 4 and 5 on your own, both giving you examples, one as a difference of cubes and the second as a sum of cubes. both having a greatest common factor to first factor out. Once you get your answer, play the video back to check. Here are your answers to problem 4 and 5. 4 having a GCF of 2w. After factoring it out, we have our binomial 27w cubed minus 125z cubed. We could write that expression as a difference of 2 cubes, in which we could follow along with the difference of cubes model and get our 2 factors. In our answer, don't forget to write our GCF out in front, which happens to be 2w. In problem number 5, this was an example as a sum of cubes, first taking out the GCF of y cubed, leaving us with the expression x to the 6th plus y to the 6th. You can write that expression as 2 terms being cubed, but it's a sum of 2 terms being cubed, so we have to use the sum of cubes model to write our factors. Again, once you write your 2 factors of the binomial, don't forget to write your GCF out in front to represent all the factors to the original expression. Going on to problem number 6 is going to be a little bit different than the previous problems that we've done. In this case, again, we're going to check to see if there's a greatest common factor, in which there is not, since there is no number that could go into 8 and 5 other than 1. In addition, there is no variable that those 2 terms have in common. Since it is a difference of 2 terms, thinking back to our last chapter, we did talk about a method of factoring called difference of squares, in which if we could write this expression as a difference of 2 terms being squared, then we know the answer would be, or the factors would be, a plus b times a minus b. But as you can see, the 2 exponents we have in the terms are 3, or cubed. So we know it's not going to be a difference of squares. If there's no GCF and it's a difference with 2 terms being cubed, let's check to see if I could write it as a difference of 2 terms being cubed. However, in this case, although we could find a term that multiplies times itself 3 times to get 8y cubed, which is 2y, there is no term or value that would multiply times itself 3 times to get 5x cubed. So since I can't write it as a difference of squares or a difference of cubes, in this case we cannot factor it. Therefore, this is a prime expression, meaning we cannot write it as factored form or 2 expressions multiplied times themselves, which would equal the original expression we have in 6. This is a prime example since it is not factorable. Please let me know if you guys have any questions on the notes,